All right, so we're going to go ahead and begin by looking at questions out of our homework. And we're going to start with 2.3. And 2.3 is functions. And we're going to begin now with question 5. And question 5, what we need to do is we need to determine where this function is increasing, decreasing, and where it remains constant. Now, the key important part is to make sure that we label it on the x-axis, not the y-axis. So if I look here, we read from left to right. So this would be going down, and then this half goes up. So let's talk about the decrease part here. So we'll do the decrease part first. Now, label on the x, not the y-axis. So the decrease part is going to be negative infinity. And where does it stop decreasing at? It stops decreasing at, not 0, it stops decreasing at negative 1. What about the increase part? Okay, the increase part would be negative 1, and it's going to the right, so negative 1 to positive infinity. And is there a constant part at all? No, there's not. But we have to make sure, again, that we label on the x-axis. So this is the decrease half. This is the increase half. So it decreases from negative infinity, stops decreasing at negative 1, starts increasing at negative 1 to positive infinity to the right. Okay. Next, we're going to look at question 8. So let's go ahead now and look at question 8. Okay. And again, we're in 2.3 here. Get this set so it looks right. Okay, so 2.3, we're going to look at question 8. And question 8, we want to find out if this is a function or not. I'm not having you get the domain or the range. I just want you to tell me if this is a function. Well, is this a function, yes or no? How would I tell if it's a function? How do you tell if an equation is a function? Has it been or can it be solved for y? Has it been solved for y? Yes. So would this be a function? Yes. So that's all you need to write on this one is yes, that it is a function because it has been solved or can be solved for y. What would make something not a function? Well, if it had like a y squared or y to the fourth or y is underneath the square root, things like that would make it not a function. But this one has been solved for y, so it is a function. Question 10. Give the domain and the range. So here's our graph. And remember, the domain is your values of x. Range is going to be the values of y. So here's our picture. And let's do the domain first. We're going to follow the graph. I'm going to start at the left-hand most corner. Now, it's not a function. That doesn't matter, but it's not a function. Why is it not a function? It breaks the vertical line test here, doesn't it? So that make it not a function. Now, let's do the domain, the values of x. If I start here, this is starting at negative infinity, okay, back here. And what's happening as I go to the right? It keeps going, right? It keeps going further and further to the right, and it's going to go to positive infinity. So my domain would be negative to positive infinity. What about the range? Okay, well, if I look at the range, it's actually going to start clear down here, right? So what happens is it's clear down here. If I follow it, what's it doing? It's going up. Okay, and it's going to continue to go up. And where does it go up to? Positive infinity. So your domain and your range are both negative to positive infinity. Are we okay with that one? 2.4. We'll begin with question 6. And 2.4, we're talking about the slope. So let's look at question 6. And for question 6, what we need to do is we need to find our slope. Slope is also called the average rate of change. To do that, we need to come up with two ordered pairs. So from April through December, the stock price of the QRS company had a roller coaster ride. The chart below indicates the stock price at the beginning of each month during that period. Find the average rate of change in the price per month between June and September. So let's go ahead first and make sure that we have the numbers for each month. So we're going to add 1 each time. So April is x equals 1. May is going to be 2. June is 3. July is 4. August is 5. Okay, September is going to be 6, 7, 8, and 9. Now, what we need is we need ordered pairs. And this is your x value. The price is going to be the y value. It tells us specifically which months to use. And which months do we need to use? We need to use the June and the September. So let's come up with our ordered pairs. And what about June? What's June going to be? Well, June is here at 3 for the value of x for the month. And what is its price? 89. Then we look at September. Okay, when we look at September, it's at 6, and the price is 111, right? Okay, so that's what we've got. Now, what do we need to do? We need to find the slope. So it's 3, 89 for my first ordered pair. The next one is 6, 111. I'm going to label this x1, y1, x2, y2, and you're going to use this formula. y1 minus y2 over x1 minus x2. And I'm going to leave that for you to finish. So you've got your values of x from that, your values of y, they make those ordered pairs. You're going to have to find your slope. So you'll plug your values in, work it out, calculate it out, and that's going to give you the slope. Does that make sense now? Okay. All right, so that was question 6. Question 9 is another application. So I'm going to read it, and then I'll put it up on the screen once you've got this one copied down. So Northwest molds plastic handles, which cost 50 cents per handle to mold, and the fixed cost to run the molding machine is $4,664 per week. If the company sells the handles for $4.50 each, how many handles must be molded and sold to break even? So let's talk about what we're doing here. When you go to sell a product, what goes into the price of that product? Well, multiple things. How much it costs to produce it, right? Sometimes it might cost a lot more to produce an item that you don't produce many of, because you still have those initial startup costs. Now, what we want is we want to break even. And when I want to break even, that means the profit is going to, or sorry, not the profit, but the revenue. Well, let me make sure we have it right here. Okay, we know we have cost, right? And then we have the revenue, and that equals your profit. We want them to break even. That means my profit is going to be 0. That means, if I use the correct words here, the revenue equals the cost, right? So what you charge for that item and get out of that item needs to equal the cost. That way you break even. Okay, break even means profit is 0. And we know that profit is defined as the revenue minus the cost. Now let's talk about our equations here. Let's talk about the revenue. How much do I sell these handles for? Can someone tell me? It says in the question that I sell the handles for how much money? On question 9 here. I'll put this up so we can see it. Yep, $4.50, right? Okay, now, do I know how many handles I'm going to sell? No, that's unknown. So revenue is going to be $4.50 times X, because X is the number of handles sold. Okay, we've got to build our equation. And we're going to be doing a lot more of these today. This question is kind of a preview of what's going to be happening today when we build equations. So that's the revenue. Okay, so if I sold 2 handles, my revenue would be $9, right? Plug in the value for X. That represents the number of handles that you sold. Multiply it by $4.50, that's the price. Now, what about the cost? Okay, how much does it cost to mold each handle? Each handle cost me 50 cents, right? So my cost then is going to be 0.5x, but I also have a fixed cost. Okay, this is called a variable cost. The more of these I produce, the more it costs. Okay, each handle costs money. But there are also called fixed costs. And fixed costs would be things like rent, payment on the machine, payment of employees' wages. Those don't change. So our fixed costs are $4,664. So you got your revenue, right? So that's 450x. That's how much each one is sold for, $4.50. What about the cost? Each handle is 50 cents to produce that handle. It has a fixed cost that, no matter what, is $4,664. You can finish it from here. So what am I wanting you to do? I'm wanting you to take this equation and solve it, right? So take this equation, solve it, find the value of X, and that's going to be how many units I need to break even. So I've got it all worked out for you for the most part. You're going to have to finish it. So you just take your equation and solve it. We've got 2 more to look at. So we're now going to look at question 14 and then question 15. Okay, question 14. I didn't give you any place to graph it. I should have been more careful and provided you with a place to graph it there. But question 14, I want you to graph it and give the domain and range. And I didn't give you a graph to graph it, but you can add one to the side. Okay, so let's look at what we've got. We've got 2y plus 12 equals 0. Now, I want to graph this line. Okay? If you only have one variable, It's either a vertical line or it's a horizontal line, depending upon if you have the x or the y. If you've got both variables, it's a diagonal line. Okay? We only have the y. So the only thing I can do is I can solve this for y. So let's go ahead and solve this for y. And then we'll see what we've got. We only have one variable. Right? In this case, it's a y. So we're going to go ahead and solve this for y. So I'm going to move that 12 over. And now we've got 2y equals a negative 12. We'll divide by our 2. And that's going to give me y equals now a negative 6. I only have the variable y. It's either going to be a vertical or it's going to be a horizontal line. How do I remember? Well, I'm going to go ahead and graph it. And what I do is I remember where the y is. Okay, y is the vertical part. So we're going to find out where y is negative 6. So this is your y-axis here. And this is, of course, negative y down here. We're going to go down 6 units. So it's right there at negative 6. Now, which way is it going to go? It's not going to go up and down, right? Because it doesn't go through the x-axis. It goes through the y-axis. We don't have any x's. So therefore, it's in this case, we only have a y part. So in this case, it's going to be a nice horizontal line. Okay? And it goes through that negative 6. Now, what would my domain and my range be? Can anyone tell me what the domain would be, the values of x? Does anyone want to take a guess? Okay, very good work. Negative to positive infinity, right? Because left and right. What about the range? What would that one be? Range is the y value. Can it go up or down any? No. It's fixed. And what is it fixed at? Negative 6, right? Because this is your positive y. This is your negative y down here. We're looking at the negative 6. So your range then would be negative 6. And I use curly brackets because that's the only number that it can be. It's always fixed at negative 6. This is also called a constant function. So if you ever see a question talking about a constant function, that means it's a horizontal line. Horizontal lines are constant functions. And I didn't give you any graph paper on the side for that, so just add it somewhere to the question. Question 15 is the last one. And we want to give the domain and the range and also sketch the graph. So 15. So 15, we've got g of x equals x minus 4. Now, sometimes it's helpful to remember that any function, h of x, g of x, f of x, okay, that's going to be y. So this is the same as saying y equals x minus 4. And to graph a line, what do we need? We need a point, right? And we need a slope. There's no number in front of the x. So if there is no number in front of the x, that's like having a 1. So my slope is 1, and my y-intercept is an ordered pair, and that would be 0, negative 4. So if there's no number in front of the x, what do we use? We use a 1. Y-intercept, where did that come from? That came from the b. How do I graph it? Okay, well, to graph this line, we first find our y-intercept. And our y-intercept is at 0, negative 4. So that's going to be down 4 units. Now, what is my slope? M. 1, but I'm going to write that as 1 over 1. So I'm going to have to go up 1 unit and over 1 unit. So we're going to go up 1, and we're going to go over 1. So that makes my new dot right there. And you can label it if you would like. If I want to label that, that would be at 1, comma, negative 3. You do not have to label them. A lot of times I do just to make it easier. Now we've got that line, or those 2 points. We can connect them together and make our line. All we need, again, is 2 points to make a line. So there's that. We also need to get the domain and range. Does anyone know what the domain and the range of this would be? Yep, and it's going to be the same for both, isn't it? All diagonal lines have a domain and range that are negative to positive infinity. So every diagonal line is going to have the same domain and range. That now should take care of the questions out of 2-4, unless anyone has any more. Do we have any others out of 2-4 to look at? Anything else to add to the list? No? Okay. So we're now going to go ahead and start the next section. And I've got a new homework packet for you and a handout as well. These out here. I do what? Yeah, you can turn it on Thursday if you like. I got one up there. I'll get it for you real quick. You're welcome. Right. Get you the next packet as well, or the next sheet here. So here's a handout that really helps when you go to work with equations and build these equations. This is the absolute easiest way to work through these. There's a handout that you're going to get in a moment. And this is going to be the absolute easiest way to find these equations. You need it. You're welcome. Everybody got the homework packet now? And everybody's got the handout. Oh, thank you very much. Let's stick together. What we're going to be looking at today is we're going to be talking about how to build equations of lines. You have probably seen this done in previous courses, in elementary algebra, if you took that course, in intermediate algebra, if you took that course, or if you took it in high school or some other place. You have probably done this a lot. We are going to be finding equations of lines. And when we find equations of lines, there's 3 ways to do them. We can either find the equation of a line when you have a point and a slope. You can find the equation of a line when you have 2 points. And you can find an equation of the line when you have a line equation and another point. So we're going to be looking at how to find these equations. And we need to first start off with our two ways that we can write our answer. There's two different ways that we can write answers for line equations. We can either write them in slope-intercept form, which is this, which is y equals mx plus b. Okay, that's slope-intercept form. And some questions, you may write your answer in slope-intercept form. Others may want it in standard form. And standard form is ax plus by equals c. A, B, and C are capital letters because they have to be integers. So A, B, and C are integers. So no fractions or decimals. And A must be positive. So when we look at standard form, the x and the y are on the same side. Now, A, B, and C are positive, and y are, I'm sorry, not positive, but they're capital letters. Why are they capital letters? Because that means they are integers. So no fractions or decimals are allowed in standard form, and then the A has to always be positive. So if we get an equation that starts off with a negative, it's not in standard form. Let's do two of these where we convert from slope-intercept to standard. So we're going to convert these to standard form. How would I convert this to standard form? So this is what I want to do. Okay, I want to make it look like this. Well, first off, in standard form, can we have fractions or decimals? No. So the first step to make it in standard form, this right now is in slope-intercept form, which is the most common way of writing your answers. But in some cases, they may want standard form. Okay. And how do we convert this to standard form? We clear our fractions. So we begin by multiplying it all by 3. And that leaves me then with 3y equals, those cancel, 5x, and don't forget the 3 times the 6. That makes it an 18. Now, what do we need to do to get it in standard form? We've got to move that 5x over. All the fractions are gone. Okay, but we're not completely done yet. Why is this still not in standard form? Right, because if you remember, the a, the number in front, cannot be negative. So the x cannot be negative. So how do we get rid of that? We just distribute a negative through, changing your signs. So that then makes it what? That then makes it a positive 5x, right? A minus 3y equals a minus 18. And that is your answer in standard form. Okay, so that's going to be your answer in standard form. Students generally do not struggle at all with slope-intercept because you're used to doing that. Slope-intercept is you just solve it for y. Standard form, the x and the y are on the same side. Make sure the x part's positive and no fractions or decimals are allowed. Let's do one more. And let's convert this one to standard form. So we're going to convert this one to standard form. And let's see, I give you a minus 3y plus 7x equals 2/5. So right now it's not in any form at all, right? It's not in slope-intercept, it's not in standard form. I want this to be in standard form. First off, it's not in the correct order. X and Y's are not in the correct order. The X always goes first, and we need to clear out the fractions. So let's get rid of that 2/5 by multiplying everything by a 5. That is going to clear out and take care of all of our fractions. So minus 15y, 5 times 7, that makes it a 35x. 5's cancel, and that leaves you with a 2. It's not in standard form yet, because to make sure it's in standard form, what needs to go first? The x. So we're going to rewrite this in the correct order, which is 35x minus 15y, and that's going to equal 2. So that is what we're working with in standard form. So that is in standard form. A lot of times, your answer will need to be written in standard form. You've got to watch the directions. It will either say slope-intercept or standard. Now, notice that handout that I gave you. Not the homework, but the handout. This is going to be very beneficial when we go to find our equations. Now, there are 3 different scenarios. You can have a point and a slope. That's the first one. You can have 2 points, or you can have a line equation and a point. This is the absolute easiest way to handle these questions. They're flowcharts, and you just follow the directions. It's like a recipe. So the first one that we're going to be looking at is we're going to be finding the equation of a line when you're given a point and a slope. And so if you have a point and a slope, you're going to follow it down, and here's the formula that you're going to apply. You're going to apply the point-slope formula. And then you either write your answer in standard form, or you write it in slope-intercept form. But you just follow the directions. A lot of times, students struggle with this because they do not use the flowcharts. You don't have to remember any formulas. All you have to do is follow the directions. Follow it like a recipe. So we're going to do 2 of these. And then we'll do 2 where you have 2 points. And then we'll do 2 of them where you look at parallel and perpendicular lines. I'm going to do 1 in standard form and 1 in slope-intercept form. We'll do the slope-intercept form first. So we're going to begin by finding the equation in slope-intercept form. And you're going to be given this. You're going to be given the point 4, -2, and you're going to have the slope provided of 7. So where do I begin? Well, let's first think about what we have. What do we have here? We have a point and we have a slope, right? So that means we're going to use the first page of this flowchart. Because what does it say? It says, find the equation of a line when you're given a point and a slope. And that's what we have. We have a point and we have a slope. Okay, so what does it say to do? Use the point-slope formula. So we're going to go ahead and do that. So let's write up our formula. We label our ordered pair x1 and y1, just like we used when we found our slope, our midpoint formula, and the distance formula. So label them just like that. Now we plug in our values. So then we have y minus, watch out for double negatives, a minus 2 equals 7 times x minus 4. Now, we have done that. Now, what's our next step? So here we are. We're here. Which way do we want to go? Directions tell us slope-intercept form, so that's here. What does it look like? Y equals mx plus b. So we're at this point. We need to clean it up. So double negative here makes this positive. We're going to distribute that 7 through. So that is then y plus 2 equals 7x minus 28. Which way do you want to go? Slope-intercept. And what does slope-intercept look like? That. You don't have to remember anything. It's all contained in the flow chart, in the directions. So that means we need to move that 2 over. And now we've got y equals a 7x minus, it looks like, 30. And that is your final answer. And that is in slope-intercept form. Absolute easiest way to do these. A lot of times students get confused. If you follow the directions on that flow chart, you will not have trouble at all with these. If you try to do other techniques, it's not going to work as nicely. Let's do another one. This one, I'm going to have you write in standard form. And you're going to be given again a point and a slope. So let's say you're given 3, negative 1 for the point, and you've got a slope of minus 4/3. So what we want to do is first look at what we've got. What do we have? Point and a slope. So we're still using that first page. And you can use these flow charts also on your exam, so you do not have to memorize anything. So we want it in standard form. So what does our flow chart say to do? We're on our first one. Use point slope. Okay, follow the arrows. And that is y minus y1 equals m times x minus x1. And we label our ordered pair x1, y1. Okay, we're going to go ahead and fill it in. Again, watch out for double negatives. So that's y minus a minus 1 equals minus 4/3 times x minus 3. All right, so now we're going to go ahead and clean this up, and then we're going to get it in standard form. So double negative makes that positive. I'm going to make this a minus 3/1, and I'm going to just distribute through. We've got to clear the fractions out anyways. We could reduce them down, but I'm just going to clear them out. So let's go ahead and work with our double negative. That makes it a positive 1. Now we're going to distribute our fraction through. So that makes it a minus 4/3 x. And minus 4 Notice I wrote that minus 3 as a minus 3 over 1. So minus 4 minus 3, negative and negative makes it a positive 12 over 3. And you could write that as a 4. Okay, it doesn't matter. You could rewrite that as a 4. Doesn't matter because we're going to clear the fractions. So how do we clear the fractions? We have to multiply it all by what now? Yep, looks like 3. So let's do that. So multiply it all by 3. And that leaves me then with 3y plus 3 equals minus 4x plus 12. Now, we want this in what? Standard form. Okay? Look at your flow chart. What does it need to look like? That. That's what it needs to look like. Okay, so we're going to go ahead and do that. So let's add that 4x over and subtract our 3. Now we've got it. All right, because now what do we have? We have 4x plus 3y and 12 minus 3. 12 minus 3 makes it a 9, doesn't it? Okay. Is this in standard form? Yes. How do I know that it is in standard form? It's in standard form because the x's and the y's are on the left-hand side. The x is positive, right? And no fractions and no decimals. So that's how we know we are done, and that's when we can stop. So these were finding the equations when we were given a point and a slope. Now we're going to look at some where you're given 2 points, and that's the second page. This just makes it so much easier than any other way of working these out. Use the flow chart. Okay, the second page, what does it say? Find the equation of a line when you're given 2 points, right? So, what do we do first? New step, we find our slope. After we found the slope, then what do? Use our point slope formula, and then we either write our answer in standard form or we write it in slope-intercept form. It's the same as what we did, it just has one extra step. Okay, so now we're going to go ahead and find the equation. Bless you. When you're given 2 points. And we're going to find this equation, and we're going to write it in, let's do this one in standard form again. And in this case, you're going to be given 2 points. 5, negative 3, and how about 8, 1? So this one is pretty much the same as the last one. All right, we just have one extra step. So what do we need to do? We can't just use the point slope formula. We look at our flow chart. What does it say to do first? All right, it says find the slope. So that's what we're going to do. We're going to write up our formula, and we're going to find our slope. So our formula is m equals y1 minus y2 over x1 minus x2. And this is x1, y1, x2, and y2. So go ahead now and fill in your formula. Again, watch out for double negatives if you have any. So you've got minus 3 minus 1 over 5 minus 8. Because make sure your y's go on the top. X's go down below. Minus 3 minus 1, that makes it a minus 4. And 5 minus 8, that's a minus 3. Double negative makes that a positive 4/3. Is everyone all right with that so far? Okay. Now, what's the next step? Follow the flow chart. What does it say to do next? It says use the point slope formula. So here's our slope. We found that. And we also have our points. Now you can use either point, it doesn't matter. I'm just going to use this one here. So I'm going to use the 5, negative 3. So we're now going to apply or use the point slope formula. And I'm going to use the point 5, negative 3. And we're going to use that slope that we found, which was 4/3. Okay, so now we apply our point slope formula, which is y minus y1 equals m times x minus your x1. Okay, so here's that part. Okay, what's next here? Plug in our values. So x1, y1, plug the numbers in, and that's y, watch out for double negatives, y minus a minus 3 equals 4/3 times x minus 5, right? Okay. Now, what do we want? We want our answer, and let's go back and make sure, we want our answer in standard form. So we just use the slope-intercept formula, the point slope formula, and we need to get this in standard form. So what do we know about the double negative? Well, that's going to make that positive, and we're going to distribute the fraction through. So now we've got y plus 3 equals 4/3 x, and make that over 1 if you need to here. 4 times a negative 5, that's a minus 20. 3 times 1, that's a 3. Now, we want this in standard form. Can we have fractions in standard form? No, we cannot. So how do we clear them out? Multiply it all by what? Multiply it all by 3, right? Okay, so let's do that. And when we multiply it all by 3, that leaves us then with a 3y. 3 times 3 is 9. 3's cancel, leaving you with a 4x. 3's cancel, that leaves you with a minus 20. We want it in standard form. So what does standard form look like? Let's make sure we're understanding what standard form looks like. Okay, standard form is that. So we need to make this look like that. That's very simple to do. Move that 4x over. Move the 9 over also. Okay, so now we have a minus 4x plus 3y equals minus 29. Is this in standard form? Not completely, right? We're almost there. Why is it not in standard form? Because of the negative. So how do we get rid of that? Distribute a negative through. Now we have it. And now it's in standard form, which is 4x minus 3y equals a positive 29. And that's it. The applications are going to work the same way. I'm going to work out one of the applications, and then you can finish the others. So I'm going to work out, that doesn't matter here, I'm going to work out 10 from your homework, and you can do 9. 9 is the same as 10, but I'm going to work out 10, and this is from your homework here, from that homework packet 2-5. And I tried to make them easier. I made it multiple choice so you could figure out if you were even on the right track or not. So on some of these I made them multiple choice, some of them I did not. The ones I made multiple choice, I did that on purpose so you'd make sure you get the correct answers. The others I did not. So I made these multiple choice so you could tell which one it is. So that way you know if you're on the right track or not. We're going to do 10. So a driver wants to gauge the fuel efficiency of her vehicle at speeds 30 miles an hour and above. She notices that traveling at an average rate of speed of 45 miles per hour, she gets 39 miles per gallon. Whereas an average rate of speed of 50, her car gets 29. Find the linear equation that models gas mileage Y for the average speed of the car X. Okay, so Y is going to be the mileage. X is the miles per gallon. So make sure I said that right. Y is the gas mileage. X is the speed. So Y is the gas mileage. And X is the speed. Okay, so we have mileage and we have the speed here. Make sure I write that in the right order here. I just want to at least spell it right. So that's going to be your gas mileage. That's going to be your Y. So X is going to be the speed. So we need to make sure we put them in the correct order. Okay, let's get our two ordered pairs. So what do we know? She's traveling at 45 miles per hour. So that's your X. X is the speed. Okay, so X is the speed. So that's 45. And what's her miles per gallon? 39. Then she increases her speed to 50. And when that speed is 50, what's your miles per gallon? 29. So it's going down. Your slope should be negative. Why should your slope be negative? If we think about this, as you drive your car faster, we know from common sense, as we drive the car faster, what happens to the miles per gallon? It goes down, right? We know that. That's common sense. My slope here should be negative because the faster I go, the lower the gas mileage is. What do we have here? We have two ordered pairs. We need to find our equation. So what are we going to use? We're going to use that flow chart. And let's refer back to that flow chart. We're going to be on the second page. Why are we on the second page? Because what do we have? 2 points. Okay, this is just following the directions. We're on the second page because this one says, find the equation of a line when you're given 2 points. What does it say to do? Calculate the slope. So we're going to do that first. So M is y1 minus y2 over x1 minus x2. And there's x1, y1, x2, y2. So plug in your values here. And that's going to then be 39 minus 29 over 45, right? Minus 50. 39 minus 29, that's a positive 10. 45 minus 50, that's a minus 5. And what does that come out to give you? That gives you a minus 2. So let's take a moment to talk about what that is. What does that minus 2 mean? For every mile that I increase the speed of the car, I lose 2 miles per hour, or 2 miles per gallon. Right, so every time I increase the speed by 1 mile an hour, I lose 2 miles per gallon. So there's our speed, right, which is x. Y is the gas mileage. Now we can go ahead and get this in our slope-intercept form. So we have everything that we need. Let's go ahead and do that. So what are we going to do next? We're going to use the point-slope formula. Which is y minus y1 equals m times x minus x1. And I always like to write my information down. So we've got a minus 2 for the slope. That's over here. And I'm going to use that point, 45, comma, 39. Fill it in. This again is your x1, y1. So that's going to be y minus 39 equals minus 2 times x minus 45. So we're going to go ahead and distribute through, and we'll solve this for y. So distribute that negative through. Make sure you're very careful with that negative when you distribute it through. It's going to change the signs, so that's going to make that a minus 2x. Double negative makes it a positive 90. And then we've got y minus 39. We need to get this in slope-intercept form. So I'm going to go ahead and add 39 to each side here. Okay. And then when I do that, it gives me 90 plus that 39. That's 129. And that gives you y equals now minus 2x plus 129. By the way, how can you check and make sure it's correct? You can always check by plugging in your point. Right? So if I plug in that 45, I better get out that 39. So let's check that real quick. Minus 2 times 45. That's a minus 90. Add to that 129, and what does that give you? 39. That's what you want, right? You plug in the x, you should get the same y value out. Or not the same value, but the one that you need out. So there's your equation, and that is in slope-intercept form. That was question number 10. That's from your homework. That was question 10. You can do 9 the exact same way. Question 9, you're going to be looking at, I believe it's the number of snakes in acres of land. Very, very similar though. We have one more set of problems to do. And this is going to be when we want to find the equation of a line when you're given a point and another line equation. And this is our last flow chart. Let me make sure we're on the last page here. This is the one we want, last page. Okay. Find the equation of a line given a point and another line equation. So, what does it say to do? Take your equation and solve it for y. Then you find your slope. Now, if it's parallel, you use that same slope. You don't change it at all. If it's perpendicular, you're going to use the negative or the opposite reciprocal. Either way, it goes back to point slope, and then we either write our answer in standard form or in slope-intercept form. So the only difference here is parallel and perpendicular. So parallel means we keep it the same. We don't change anything at all. Perpendicular means we use the negative or the opposite reciprocal for the slope. So we're going to do 2 of these, and then we'll look at some special cases, and that's going to finish up the lecture for today. So we've got a few more minutes here. Now we're going to be looking at finding equations when you're given a point and another line equation. And let's do this one in standard form. And you're going to be given a point, let's say -5, +2, and we'll do a perpendicular one. So let's say it's perpendicular to, how about 3x plus 4y equals 7. Okay, students struggle with these. Easiest way to do them, follow the directions. So what do we have? We have a point and we have a line equation, right? So that tells me now I go to the 3rd page. And we follow the directions, and these will be very easy. If you try to do other things, it's going to be more difficult. So this way, absolute easiest way to do them. What does it say to do? It says solve that equation for y. So basically get it in slope-intercept form. So let's go ahead and do that. First thing we do is we solve this for y. So 3x plus 4y equals 7. So move that 3x over. So 4y equals now a minus 3x plus 7. Divide by my 4. And we now have y equals a minus 3/4 x plus 7/4. And I need to find that slope. So that's minus 3/4. So I just took the equation and I went and I solved it for y. Now, is this the slope that I'm going to be using? No. Why not? Because it says what? Perpendicular. If it would have said parallel, we would be done. We could go to the next step. This one has more to it. We want to go down the perpendicular side. So we need to use the negative reciprocal slope. So we're going to be using now this. So we're going to use m equals 4/3. This is what we're going to be using. Why are we not going to be using the minus 3/4? Is because that would be parallel. We don't want it to be parallel. We want it to be perpendicular. Now, what does it say if it's perpendicular? Negative or opposite reciprocal. So you flip it over. So if I flip this fraction over, it becomes 4/3. Okay, it's negative, so I change that, and that makes then a positive what? 4/3. So that's the slope I'm going to be using. So I'm going to use that. What do we use it in? We use it in point slope formula. So now we're going to use point slope. And we've got a slope which is now 4/3, and we've got that point that we haven't used yet, which is 5/2. So that's what we've got right here. Write up your formula. So that is y minus y1 equals m times x minus x1. There's x1, and there's y1. Plug your values in. Again, watch out for double negatives. So that's going to be y minus 2 equals 4/3 times x minus a minus 5. And watch again out for this double negatives. Double negative here. That makes that positive. And so now we've got y minus 2 equals, when we distribute through, 4/3 x. 5 times 4, that's a 20 thirds. And what do we want? Well, we want this in, if you remember, standard form. So, can we have fractions in standard form? Nope. So what do we need to do? Multiply it by 3. And multiplying it all by 3, we now have 3y minus 6 equals 4x plus 20. We want it in standard form, so move the 4x over. Add the 6. So now we've got a minus 4x, right? We've got a positive 3y, and that equals 26. Is this in standard form? We're almost there. We're not quite. Standard form, we can't have that fraction. Or sorry, that negative, I mean. So put the negative out in front. Distribute it through. Bless you. And what are we left with now? We are now left with 4x minus 3y equals minus 26. And that is your answer in standard form. Okay. We'll do one more of these, and then we'll look at some special cases real quick with the horizontal and the vertical lines, and that'll be it for today. So let's do one more of these. This one's going to be parallel. This one will actually be a little bit easier. And we're going to do this one in slope intercept. So we're going to find our equation, again in slope-intercept form. And you're going to be given this. You're given the point. How about 1, 4? And I want it to be parallel to this line, which is x plus 4y equals 9. So this is now what we have. We want it in slope-intercept form. Now, what's the difference between the parallel and the perpendicular definitions? Okay, parallel, we don't have to change the slope at all. Right? We keep it the exact same. Perpendicular, we would have to flip it over and change the sign. So what do we have to do no matter what? First thing, use your flow chart. Okay? Solve it for y. That's it. So x plus 4y equals 9. We're going to move that x over. So 4y equals a negative x plus 9. We'll divide by our 4. And we'll write this out a little bit neater. So now we've got y equals a minus 1/4 x plus 9/4. And what would my slope be? Yep, negative 1/4. Is that what I'm going to use? Yes. So now we're going to use m equals a minus 1/4 because this is parallel. Okay, if it's parallel, that's what we use. We use the same slope. Okay, so it's parallel, so we're going to use that same slope. Now, what have we not used? We haven't used the point. So let's rewrite it. And we're going to use that point slope formula. Which is y minus y1 equals m times x minus your x1. And we've got that point 1/4. And we found our slope to be a minus 1/4. x1, y1, fill in the pieces. So let's go ahead and plug this in. Y minus 4 equals minus 1/4 times x minus 1. Okay. Distribute that fraction through. And then we're going to clear it. We do want it in slope-intercept form, but we're going to go ahead and clear that fraction out just to make it a little bit easier. Double negative makes it a positive 1/4. Yeah, I'm going to go ahead and clear these fractions out. I'm going to multiply this all by 4. And that leaves me now with 4y minus 16 equals a minus x plus 1. We want this in slope-intercept form. So if we want this in slope-intercept form, we need to solve for the variable y. I'm going to go ahead and pass out the sign-in sheet, but we have 2 more questions that we're going to be looking at. So, sign the sign-in sheet. We're going to go ahead and finish this out. So we want this in slope-intercept form. So I'm going to add that 16 to each side. So 4y equals a minus x plus 17. I'm going to move it over. Divide by our 4 everywhere. And now we've got it. So now we've got y equals a minus 1/4 x plus 17 over 4. For the very last part of this section, we're going to talk about vertical and we're going to talk about horizontal lines. So a horizontal line is y equals some number. And that has a slope of 0. So if you have a slope of 0, it's a horizontal line. It's a y line. Now the opposite of that is going to be a vertical line. If I have a vertical line, if you remember, vertical lines have an undefined slope. So vertical line is going to be an x equals some number. And it has a slope that is undefined. So m equals undefined. Now, this is the easiest part. Okay, these are kind of like what we did when we looked at absolute values. Remember, on some of the absolute values, it was either like true or false, right? And you could jump straight to the answer. These are kind of similar. If your slope is 0, it's a y line. If your slope is if your slope is undefined, it's an x line. Do not try to make these more difficult than what they need to be. So we'll do probably 3 of these, maybe 4 if we have time, if we need to. And we're just going to find the equation. And normally these are all in standard form, because some of them you can't even put in slope-intercept. So we're going to find the equation. And let's say you're given a point 5, 12, and your slope is undefined. Okay. So we can't use our point slope formula. Why not? Because we cannot plug in something that is undefined. So we need to remember our definition. And our definition says if our slope is undefined, that means it's an x line. So what is the x component of your ordered pair? Remember, this is your x. This is your y value. So this is undefined, so it's going to be an x line. And what's your x component? 5. So what would your answer be? Simply, x equals what? 5. Right? Undefined vertical line. Right? Sorry about that. Undefined vertical line, x line. So in this case, x equals 5. Let's do another one. Find the equation again. And let's say you're given 8, negative 10, and your slope is 0. Now, we could work this out with the 0. And we could use the point slope formula with the 0. But we really don't need to. Because if my slope is 0, what type of line is it? If my slope is 0, it is a horizontal line. So horizontal line is a y line. And what's the y component of your ordered pair? Negative 10. So my answer would simply be y equals negative 10. That's it. Let's find the equation again. And let's say you're given the point 8, negative 12, parallel to y equals 5. Okay. When I say parallel, that means they're going to be the same. So what's parallel to a y line is another y line. So this is parallel to y equals 5. So my answer would be y equals, and what's the y component of my ordered pair? Negative 12. So this one would simply be y equals negative 12. One more. And this will be it. And if you haven't finished your homework, you can turn it in on Thursday. So if you want to turn it in today, you can. If you want to wait and turn in that homework packet on Thursday, that's okay too. You just do not want to fall too far behind. So let's do one more. And let's find the equation. And you're going to be given a point and a slope, or sorry, and a line equation again. So let's say you're given the point 9, negative 14. And in this case, I want to be perpendicular to about y equals 7. Okay. So parallel means they're the same. Perpendicular means they're the opposite, basically. Negative reciprocal means the opposite. So if it's a y line, what's the opposite of a y line? Okay, x line. And what would the x component be? 9. So that's it. So your answer would simply be x equals 9. And that's it. That's all you need to do here. What's your homework? Well, we only covered one section. So your homework is 2.5. If you have your homework from last time finished, you can turn that in. If you want to wait until Thursday, you can turn that in as well. I don't take off points for back homework. You just really do not want to fall too far behind, because it's easy to get too far behind and really hard to get caught up.